Hello everyone, today we will explore an important concept from Unit 1 of the PPL course, which is Programming Paradigms. The objective is to learn the basic principle of programming languages and programming paradigms. So let's start. What is paradigms? Paradigms can also be termed as a method to solve some problem or do some task using programming languages. Programming paradigms are important because they define the programming language and how it works. There are many programming languages are available today which follows the different programming paradigms. For example, C language follows the procedural programming paradigms, whereas C++, Java, and Python follows object-oriented programming paradigms. Programming paradigms are divided into two types. First one is imperative programming paradigms and second one is declarative programming paradigms. In imperative programming paradigms, there are three types. First one is procedural programming paradigm, second object oriented programming, and third one is parallel processing. In declarative programming paradigms, there are three types: logic programming paradigms, functional programming, and database processing approach. In this lecture, we will learn about imperative programming paradigms. Imperative programming paradigm is one of the oldest programming paradigms. Imperative programming consists of set of detailed instructions that are given to the computer to execute in given order. Imperative programming focuses on how a program operates step by step. It is called as imperative because as a programmer we decide exactly what the computer has to do in a very specific way. Imperative programming is also known as procedural programming language. Here is the example of C programming language. In this example, from assigning value to each variable to the final addition of those values, each statement changes the state of the program using sequence of statements that this program shows the addition of 10 and 20. Imperative programming is divided into three broad categories: procedural programming paradigms, second one is object oriented programming paradigms, and third one is parallel processing. Let's see the procedural programming paradigms. Procedural programming is one programming paradigms derived from the imperative programming based on the concept of the procedure call. A procedural language is a sort of computer programming language that has a set of functions, instructions, and statements that must be executed in a certain order to accomplish a job or program. To create a program, we use variables, condition statements, and functions that permit a computer to process and provide the desired output. Procedural programming often follows a top-down design where the main program is broken down into smaller subprograms to handle the specific task. Next is the advantage of procedural programming. First one is simplicity. The structure of the procedural programming language is simple and programs are generally easy to follow. Next one is efficiency. Procedural programs can be very efficient and fast, especially for the tasks that require a simple step-by-step logic. Next one is easy debugging. Because of its linear nature, finding and fixing the error is relatively straightforward. And last one is reusability. Function can be reused in different parts of the program or in a other program, reducing the code duplication. Next is the object oriented programming paradigms. Object oriented programming paradigms is a programming paradigms that organizes the software design around the objects rather than the function or logic. Here objects are the instance of the class. Objects have the attribute or state and method which having the behavior. Attribute are data associated with the object, while method are the actions or the functions that the object can perform. The four Main principle of object oriented programming languages are encapsulation, abstraction, inheritance, polymorphism. What is encapsulation? Encapsulation helps in organizing the code, protecting the data, and ensuring that the internal working of the object are hidden from the outside. Next one is abstraction. Abstraction involves hiding the complex implementation details and showing only necessary features of an object. Next one is inheritance. Inheritance is the mechanism where one class, that is child or subclass, inherits the properties and behavior from another class, that is parent or superclass. Next one is polymorphism. Polymorphism allows related classes to share some functionality while also defining their own unique behaviors. For example, a subclass can override a method of its superclass. This principle helps in making the software more modular, flexible, and easier to maintain. Next is the benefits of object oriented programming language or paradigms. First one is modularity. In object oriented programming, code is organized into classes and object, making it easier to manage. Next one is reusability. Classes can be reused across the different program and inheritance allows for the reuse of existing functionality. And next one is maintainability. Maintainability means what? In object oriented programming promotes code that is easier to maintain, debug, and extend. Next one is scalability. Object oriented programming allows for the easier to expansion of the code as requirement grows or change. Next paradigms is parallel processing. Parallel processing is an approach in which divide the big program into different parts and smaller program part is being allocated to specific processor and they all execute their task concurrently or parallelly in order of n by k, where n is the program size and k is the number of processor. Languages that support the parallel processing approach are C, C++, Java, and Python. Last topic is benefit of parallel processing. First one is speed and efficiency. By dividing a large problem into smaller tasks and solving them concurrently, parallel processing can reduce the time needed to solve the computation problem. Next one is handling large scale problem. Parallel processing is essential for problems with large dataset or complex computation. For example, scientific simulation, big data analytics, and machine learning. Improved throughput. Multiple tasks can be processed simultaneously, leading to higher throughput, especially in systems that need to process large volume of the data quickly. Resource utilization. Multiple processors or cores can be efficiently utilized to maximize the hardware potential. Thank you.